coccobacilli, and it groups together several species including Brucella abortus, Brucella melitensis, Brucella canis, and Brucella suis. All cause a systemic disease called brucellosis, but each of them has a different host and causes a different form of the disease. Now, Brucella is a non-motile bacteria that doesn't form spores. It's a strict aerobe, meaning that it needs oxygen to survive, and also it's facultative intracellular, which means it can survive both inside and outside the cell. Finally, it's urease and catalase positive, which means it produces both of these enzymes. Brucella is usually isolated on blood cultures, with biphasic methods like the Ruiz-Castañeda methods. Biphasic means that the blood culture bottle has both a solid phase and a liquid phase. Now, Brucella is a very slow-growing bacteria, so colonies usually grow in the solid medium after 6 to 8 weeks of incubation. The colonies are raised, convex, with smooth, shiny corners. On the bright side, there are now some modern automated blood culture systems, like the Bactec systems, which are more effective and can isolate Brucella after only 1 week. Neat! Now, Brucella can enter the body one of two ways. First, there may be direct contact with infected animals, and the host is different for each Brucella species. So, B. abortus is transmitted by cattle, B. melitensis is transmitted by small ruminants such as goats and sheep, B. canis is transmitted by dogs, and B. suis is transmitted by swine and rodents. In this case, the bacteria enters through skin lesions, mucous membranes, and from inhalation. The second way is ingestion of contaminated animal products such as unpasteurized milk, cheese, and undercooked meat. So, once the bacteria is inside the bloodstream, it's ingested by phagocytes like macrophages and neutrophils. Normally, phagocytes destroy invading bacteria by wrapping them up in vesicles called phagosomes, which will merge with lysosomes to form a phagolysosome. Lysosomes are round vesicles that contain hydrolytic enzymes which are released inside the phagolysosome to destroy the invading bacteria. However, Brucella has a few virulence factors that it uses to avoid destruction. First, it has the ability to escape immune recognition by using the type 4 secretion system, or T4SS for short, which is a collection of proteins that can dampen the immune response. However, some of them are not able to escape and are caught by macrophages and ingested. Inside the macrophage, Brucella uses another virulence factor on its outer membrane, called non-endotoxic lipopolysaccharide, or LPS for short. LPS inhibits the fusion between the phagosome and the lysosome, and allows Brucella to avoid intracellular death. So, once Brucella is safe from intracellular destruction, T4SS starts secreting effector molecules. There's a whole bunch of these molecules, and their exact role is not yet well understood, but what we do know is that they help the bacteria travel to the endoplasmic reticulum where it can replicate in large numbers. Now, the ability to survive and replicate inside macrophages also makes it able to travel through the bloodstream to multiple organs such as lymph nodes, the liver, and the spleen. Additionally, when the macrophage becomes too small for the growing number of Brucelli, it bursts, releasing the bacteria into the bloodstream. And from there, they can spread to organs such as bone marrow, central nervous system, bones, heart, and lungs. Symptoms of brucellosis are usually nonspecific and influenza-like, with fever, sweating, headache, myalgia, arthralgia, weight loss, and fatigue. The fever, though, has a particular trait. It's indolent, which means it rises and falls like a wave. And on physical examination, there may be hepatomegaly, splenomegaly, and lymphadenopathy. Infection may range from mild to severe, depending on the infecting Brucella species. For example, Brucella canis causes a mild disease, whereas Brucella melitensis causes severe forms. Brucella abortus mainly affects the liver and the spleen, causing sarcoidosis-like lesions called granulomas. Finally, with Brucella suis, there may be liver abscesses. When brucellosis is left untreated, signs of complications may also appear, like bone pain in osteomyelitis, headache, fever, and a sore neck in meningitis, and fever and new heart murmurs with endocarditis. Diagnosis of brucellosis is confirmed by identifying the bacteria in the blood or bone marrow by incubating cultures. However, this can take a while, so presumptive diagnosis requires serological tests like the serum agglutination test, ELISA, or complement fixation using a blood sample, which shows high or rising antibody titers against Brucella antigens. At first, IgM antibody titers increase, and several weeks later, IgG antibody titers begin to rise. Finally, the disease is treated with a combination of doxycycline and rifampin for a minimum of 6 weeks to prevent relapses. Alright, as a quick recap. Brucella is a genus of gram-negative coccobacilli which includes 4 species: B. abortus, B. melitensis, B. canis, and B. suis, all of which cause a zoonotic disease called brucellosis. They are facultative intracellular, strictly aerobe, urease, and catalase positive. It has 2 major virulence factors, which are the lipopolysaccharide, or LPS, and the type 4 secretion system, or T4SS. Brucellosis is characterized by episodes of undulant fever, arthralgia, myalgia, headache, sweats, fatigue, and weight loss. It can be diagnosed by incubating cultures from blood and bone marrow or with a serum agglutination test and is treated with doxycycline and rifampin for 6 weeks.